Okay, this video is the first one I'm doing on this new to me camera, so it might look a little different and might be a little rough. Anyway, this video is about a quiz that's going around Facebook right now called Can You Pass a Basic Math Quiz? And the answer to this is yes, you can. I've seen a variety of scores from 2 all the way to a perfect 10, middle, 4, 5. So let's work some of these problems so that you can also be scoring a good 10 and know what's going on. So, and anybody who thinks that they're going to watch this video and cheat because I'm going to work the problems and give you the answers is going to be very, very disappointed because I've changed up a lot of the numbers. Now, there's a couple of questions where I have to give you the answer in order to show you how to do the problem, but that's the exception, not the rule. So we're going to start with question number 1. And for question number 1, we're going to deal with a little bit of basic statistics. And you're going to see in a minute while I'm writing my numbers all in different colors. And let's just throw a 6 on here on the end. And throw that Oxford comma in there. Okay, it's not really an Oxford comma because it's necessary. It's not following an and. Okay, to answer question number 1. And question number 1 is, what is 8? In this context, when it's asking what is 8, it's asking about statistically. Now, statistically speaking, you have to know a few terms. And we're going to go over those real quick. This is the 3 M's of statistics, which is, at least that's what I like to call them. Anyway, they're mean, median, and mode. So let's define these real quick and find them in this example. The mean is simply the average. That's if we took all our numbers and added them up, and then we divide by the number of numbers that we have. So what I'm going to do is I'm going to take my little calculator here, get up here close so maybe you can see what's going on. Do 7 plus 8 plus 8 plus 8 plus 9 plus 6. You see that gives us 46. Then we're going to divide that by, let's see, 1, 2, 3, 4, 5, 6 numbers. So we divide that by the 6 numbers that we have. And that gives us 7.666666666. And that is our mean. Our average is 7.6. And this bar over the 6's just simply means that repeats on out without ever stopping or changing. Next term is median. And that one sounds like it should be the average, but it's not. What this is basically it's the number. That is not a hashtag, that's the number sign in the middle. So in order to find that, we need to line these up numerically. So you have 6, 7, 8, and you don't have to repeat your 8s because it's middle value. So in this example, we really need one more number to make it look better, because if you have 5 different numbers, it's a little easier to find. But right here is probably where you're going to find your median, right there at 7 or 8. In this case, I'm going to say it's probably 7. It's really probably 7.5 actually, but the last number, or last term, I'm sorry, that we're coming to is the mode. Like I said, if this was, say, a 10, no, let me add it to the other side. Say if there was a 5 down here, then as you can see, 7 would be in the middle of your numbers because you got 2 on either side. So it's a 5th number would actually make it a little easier to see. The last term we're going to talk about is mode. And what mode is the number that occurs most often. in your set of numbers. As we see, that's very obviously 8 for our mode. So 8 is the mode. And again, this is a question where I have to give you the answer to show you how to do it. But don't expect that too much. So moving on to question number 2, and question number 2 is a word problem. Everybody loves word problems. So we're going to say that Jake, let's see, Jake has 3 more than, let's say 3 more than 8. Right where you can see it, that might be helpful. 3 more than 8 times as many apples as Joan. Now, we're going to establish that Joan has Y number of apples. Now, question here is, how would you calculate how many apples Jake has? Try to write a little smaller so I got room. Okay, this question is looking for formula, not a numerical answer. So let's do what we do with word problems, break them down, find out the information we need so we can get the answer that we want. So we're going to look in here, and we're going to look out, and we're going to see numbers. Okay, so we've got 3, 8, and Y are variable. So those are our numbers. Now let's look for our action words, the words that are telling us things about those numbers. Words like more and times. Okay, so we've hashed out that information. Our action words and our numbers. So let's look at our action words and our numbers and put everything together. So we look and we see 3 more than. It's more than, made that an action phrase. So we know that's going to indicate plus 3. Okay. Now, we know it's 3 more than something. So we move on. We say 8 times as many apples. So what that tells us is we're going to have 8 multiplied by the number of apples that Joan has, because she says 3 more than 8 times more. Well, how many apples does Joan have? That's where our Y comes in. And then we have 8Y plus 3, and that's how you would figure how many apples that Jake has. Now, just as a bonus, to show you how to do the algebraic manipulation to show how many apples Joan has, to isolate Y, because we're going to get to a problem later where isolating Y is important, we have to undo the operations that are done. Because right now we have an equal sign and a blank over here. So what we want to do is we want to subtract 3, because everything you do on one side you have to do the other. So you want 8y equals negative 3. And then you would divide by 8 to undo this operation. So y equals negative 3/8. Now you can't really have a negative of a realistic object. This is just showing the algebraic manipulation. So, moving on to question number 3. Wow, this thing's already 9 minutes long. Okay, this may turn into 2 videos depending on how much time I can get. Okay, question number 3 is talking about a single number and giving us some more definitions. So we're looking at negative 3 is question mark. And let's look at our choices. Say negative 3 is irrational. Negative 3 is an integer. -3 is a prime number. Or -3 is a whole number. So let's look at the definition of these words. Okay, first off, an irrational number. Remember when we took our median back in the first problem and we got that this, where that 6 just kept on going and kept on going and kept on going and never stops, never changes. That is an irrational number because it keeps on going and never ends. Pi is an irrational number. Well, not technically, I guess, because it changes, it just never ends. Integer. What an integer is it's kind of the same thing as a whole number, but think of it more like your counting numbers. But when you look on the timeline and you have your counting numbers, 1, 2, 3, 4, etc. Those are whole numbers. As we see down here talking about whole numbers. These are whole numbers. Everything 1, 2, 3, 4, 5, you're counting numbers. Where integers come in is when the number line starts going this way from 0 and you start getting -1, -2, -3. So integers are like whole numbers, only it includes your negatives. So coming down here talking about whole numbers, starting at your 0, going this way, 1, 2, 3, you're counting numbers with no decimals. Whole numbers, meaning they don't have any parts hanging around, because we have something like this, that 0.5 is a part of a number hanging around. Whole numbers have just this, just the number itself hanging around. Okay, now 3 is a prime number. -3, I'm sorry, is a prime number. Yes and no. A prime number is a number that has only 2 factors. It can only be divided by 1 and itself. That's it. The thing is, though, since 3 is a negative number, primes are by definition positive. So it by definition cannot be a prime number. A prime number by definition is any number higher than 1 that are to the right of 1 when we're looking at our counting numbers, that can only be divisible by 1 and itself. It only has those 2 factors. So, and I think I'm going to break this into 2 videos. We're going to get to question 5, and that'll be part 1, and then we'll move on to 6 through 10 in part 2. So, let's move on to question number 4. Since this video is turning out to be longer than I anticipated, we're going to do is 2 videos. This will be part 1, and then we'll come back for part 2. Alright. Now, the slope of a horizontal line is... Now I'm going to draw out the multiple choice answers, but, well, yeah, let me do it. Slope of 0, positive slope, a negative slope, or an undefined slope. Well, to look at this answer, we've got to look at where slope comes from. And we've got to understand a couple of things. The first thing I'm going to draw out here for you is a little graph. This is your x-axis, this is your y-axis. When we talk about slope, we're talking about how quickly a line is rising or falling like this. Now, have to understand where we get that number from, and there's this formula called form called the slope-intercept form. You may have seen it before, y equals mx plus b. Now, for purposes of this question, we'll break this down real quick. M, right here, this is your slope. And we're going to talk a little bit more in depth about it. This is your y-intercept. And that's why it's called slope-intercept form. This is where your line crosses this y-axis. But for this question, that's not important. There'll be another video on slope-intercept form, which is algebra, as well as slope-point form, which is calculus. So let's talk more about slope. When we look at slope, it looks like a fraction. And it breaks down like this. Rise over run. And what this is telling us is how quickly it's moving up or down and how quickly it's moving left or right, with positive being up and negative being down, positive right, negative left. So if we had a slope that looked like this, that means from our starting point, which would be our y-intercept, we could go up 1 unit and over 2, and then we go down 1 unit and over 2, and then that gives us points to draw our line. So let's look at a horizontal line. And I'm just going to draw one somewhere randomly on the y-axis because, again, it's not important right now, our y-intercept. Okay, so we're looking at a horizontal line. So we see it's got run both directions by 1 unit at a time. So we know that our run is going to be 1 because as it's moving left and right, it is actually doing it 1 unit at a time. Now, you look at it, it doesn't rise at all. We represent that with a 0. I should have written that in a different color. Sorry, didn't mean to confuse anybody. We represent no rise as a 0. So 0 divided by 1, 0 divided by anything is going to equal a big fat 0. So the slope for this and any other horizontal line is 0. Now, the question on the quiz calls for a vertical line. So let me just throw a vertical line in there. I'm not going to give you the answer, but I'm going to give you a little information to figure it out. As you can see, this thing is not running either direction. It's rising, again, 1 unit at a time. But it's not running in any direction. So if you establish your rise or run and do the math, it will give you the answer for the vertical line. Like I said, I'm not going to give you the answer. But that should be enough information for you to figure the answer. Alright, question number 5, which is going to be the last one for this video, is how many square feet? Yeah. Feet are in 576 square inches. Now, in the quiz, they give you the hint that 1 foot is 12 inches, and that is true. 1 foot is 12 inches. But here's the key part about this question that I missed the first time I was doing it and had a duh moment. We're not talking about inches and feet. We're talking about square inches and square feet. So you have to square these numbers. You have to come and put a little exponent on them to make them square inches and square feet. So if you square 1, it's 1. It doesn't matter what power you raise 1 to, it's going to be 1, because it doesn't matter how many times you multiply 1 over and over and over and over again, it's always going to be 1. So 1 square foot is equal to 12 squared, in case anybody didn't know, is 144. So 1 square foot is equal to 144 square, that's why I get for talking and writing at the same time, square inches. So now we have to look up here and say, okay, we have 576 of these. And we want to know how many of these we have. What you do is you take 576, divide it by however many of these you have in one of these, which in this case is 144. I did the math earlier, and it gives you 4 square feet. Again, that's the trick to that problem. Alright, that was question number 5. That's going to be the end of the first part of the video since we're running up on 20 minutes. Sorry, it's a little bit longer. I'm going to put a link to part 2 if you want to see questions 6 through 10.